got this problem up on the board. We're asked to evaluate cosine of 2 theta if sine of theta is negative 1/3. So I need to use a double angle formula for cosine. I'm going to start with the one that falls directly out of the sum formula. So remember, the sum formula for cosine gives me cosine cosine minus sine sine. So that's just going to be cosine squared theta minus sine squared theta. Now, pretty clearly I have enough information to figure out this term. I can actually figure out what this term is too. I don't have enough information to figure out what cosine of theta is, because I don't have any information about what quadrant I'm in. So I don't know whether cosine is going to be positive or negative. But all I need is cosine squared, and I could get that using the Pythagorean identity. However, I think it's going to be a lot simpler to just replace this using the Pythagorean identity with 1 minus sine squared theta. Then I'm still subtracting this version of sine squared theta. And so we've got 1 minus 2 sine squared theta. That's another version of our double angle formula, and that one only requires that I know what sine of theta is. So I'm going to say cosine of 2 theta is 1 minus 2 copies of sine of theta we were given is negative 1/3 squared. Okay. So that's going to be 1 minus, I'm just going to write that as 2 over 1 times negative 1/3 squared is positive 1/9. So that would be 9/9 minus 2/9. That would be 7/9. Excellent. So we can actually evaluate cosine of 2 theta without knowing what quadrant theta is in. Kind of neat. Now, if I wanted to evaluate sine of 2 theta, we only have one version of the double angle formula there, and it's 2 copies of sine theta cosine theta. So in order to be able to evaluate sine of twice an angle, I need to be able to know both the sine and the cosine. And neither one of those is squared. So I'm going to need to know whether they're positive or negative. So with just this information, if sine of theta is negative 1/3, I don't have enough information to evaluate sine of 2 theta. So I'm going to add some information. So I'm going to say that pi is less than theta is less than 3 pi over 2. So that's just a fancy way of saying that theta is going to be in quadrant 3. Okay. With that information, now I can figure out what the cosine of theta is so that I can evaluate sine of 2 theta. Okay. Just kind of interesting that we need more information to use the double angle formula for sine than we do to use the double angle formula for cosine. Okay, so let's see. What I have here is I can draw my picture. Here's my theta, putting me in quadrant 3. I'm going to let alpha be my reference angle, and I'm going to draw my right triangle that has alpha as an acute angle in it. And then I know that sine of alpha would just be the absolute value of negative 1/3, which is positive 1/3. So I'll let the opposite side be 1 and the hypotenuse be 3. Let's call the adjacent side a, and we'll use Pythagoras to solve for it. So 1 plus a squared is 9. A squared is 8. A, since it's a side length, is positive root 8. And I can simplify that because that's root 4 times 2. And of course, root 4 is just 2. So that's going to give me 2 root 2. Fabulous. So then I can say cosine of theta, my usual 2-step process. We're in quadrant 3, so it will be negative. So remember, my choice is always to label actual side lengths as positive and just deal with the plus or minus signs separately. If your choice is to label signed side lengths, that's fine. Then you would have found that the adjacent side as a signed side was negative 2 root 2. All right, and then what we attach to that negative sign is cosine of the reference angle, which is 2 root 2 over 3. Okay, So sine of 2 theta is 2, which I'm going to write as 2 over 1, times sine of theta, we were given that's negative 1/3, times cosine of theta, we just figured out that's negative 2 root 2 over 3. So it looks like we've got two negatives, so those will cancel each other out. On top, 2 times 2 root 2 is 4 root 2, and on bottom, 3 times 3 is 9. So sine 2 theta will be 4 root 2 all over 9.